All right, everyone, welcome to ASRG World Webinars, bringing you the latest in automotive research, innovation, and education. My name is John Heldreth, founder of the Automotive Security Research Group, and we have a great presentation for you tonight. First of all, let me quickly introduce myself. As I said, my name is John Heldreth. I'm the founder of Automotive Security Research Group, or ASRG. I've worked in the automotive industry for the last 15 years or so, and recently started focusing on product security. I'm originally from Detroit, Michigan in the US of A, but today I'm living in Germany and working at Porsche Engineering. Please feel free to follow me on LinkedIn or other social media platforms. Just quickly, the Automotive Security Research Group is a nonprofit company focusing on the advancement of the automotive security industry. This is a community to support the coming together of two areas of competencies, the IT security market and the automotive market. This is a community for you, for the automotive engineer, for the IT security specialist, the beginner, the hobbyist, even for the people that are in the wrong YouTube channel. This is a community of volunteers. Our entire organization is built on the volunteer efforts of the administrative team and, of course, people like you, the members. We are trying to remove the boundaries that can occur in the automotive security industry. This could be communication, borders, finding ways to learn different solutions, making good decisions, because at the end of the day, we all have the same goals: to keep our customers, our families, our friends' data safe and secure, which can only be achieved together. If you want to get more involved, make an impact on the industry, start your own ASRG location, participate maybe in a technical committee, or be a part of a project, please reach out to us. You can find more information about ASRG at www.asrg.io or send us an email at hello@asrg.io. Just quickly, we have many locations around the world. Actually, we have 31 of them. We have over 5,000 members as well. I'd like to introduce our two newest locations. This is Barcelona, or ASRG BCN, and London, ASRG LDN. Really excited to see what happens in these two locations. Welcome to the ASRG family. We're glad that you can also participate and be a part of it. We have really some cool webinars coming up. All right. Next week, September 24th, we have AI-based security and safety anomaly detection with Mustafa and ATI. Then September 27th, this is a little bit outside our regular scheduled programming. However, this is also part of the CTF that's going on in October from ASRG and Cybersecurity Talents, or Cyber Talents. We have what is required to work in the automotive cybersecurity jobs. And this is with AJ Khan. He's in Canada from APMA. He's also leading the ASRG Toronto chapter. So really cool discussion there about how to get involved. October 8th, 2020, an overview of privacy preserving credential management for V2X communication. Wow, that's a lot to say. Kevin Henry is going to be with us from eScript. Going to be a really interesting talk. October 15, 2020, LibraCon. So talking about automated CAN message translator tool, LibraCon. Mert is going to be with us from University of Michigan, which is in Ann Arbor, Michigan, which is almost my hometown. October 22nd, 2020, we have APMA IAC, securing the complete mobility ecosystem. Colin and AJ are going to talk to us about not only securing the vehicle, but also securing the supply chain. This is really important that we don't just focus only on the products themselves, but also how they're made, because all of these attacks can happen not only during the design of the product, but also in the production of the product. If you'd like to present, please contact us at cfp@asrg.io. All right, without further ado, we have really a great presentation for you today. We have Noel Lowdon in the house. He's an investigation consultant expert at Harper Shaw Investigation Consultants Ltd. And he's going to be talking to us about Frankie and vehicle forensics, which is a little different perspective than we normally take, but really interesting topic. So without further ado, Noel, would you like to go ahead?
Hi, John. Good afternoon, everybody. I'd like to take the opportunity to thank ASRG for inviting us on today to speak about vehicle forensics. And I hope to just give you a outline of some of the work that goes on in tackling serious unorganised crime, of which the vehicle is sometimes used, and how we can maximise a modern vehicle in relation to those investigations. We are acutely aware of the work that's going on with the community around protecting our technologies in the way that they are manufactured and in the way that the automotive industry is going through a great shift in transformation. So we have one foot on the reactive of what's happening now, but we've also an eye on the future and what we've got to come and what we've got to prepare for from tackling those sorts of things. Okay, I'm just going to start with a short video. Okay, so we can see in this particular video, a vehicle is being used for a theft in respect of jewellery. But this is part of a wider criminal gang that are doing these sorts of crimes all over the UK potentially, and harvesting quite a lot of income from this type of activity. So we can see from the video the type of organised crime that can go on in this country and no doubt across the globe, and how the vehicle is used, whether it be used as a getaway vehicle or whether it be used in the commission of the offence. So in respect of that particular incident, there are all sorts of opportunities that we could do with the vehicle in order to assist in identifying offenders and prosecuting that particular offence, but also the vehicle may lead us to identify other offences which are being committed with the vehicle and part of the wider criminality of the use of that vehicle. So I'm going to talk to you today a little bit about maximising the evidential potential of vehicle data. I'm going to talk about vehicle and digital strategies, because the vehicle does link into other digital areas, and the importance of coordinating that data with other digital data to build up a rich, intelligent picture. Some of the tools that we may use in order to facilitate this type of work, and then we're going to finish off with a little bit of a case study, as John introduced, around Frankie, which is our vehicle system forensics rig that we use for training and for ethical hackers to try and hack into the system and test the vulnerabilities of a particular vehicle network that's in existence at the moment. Before I do go any further, my background is working in law enforcement, and I've done so for around 17 years in the UK, and I was dealing mainly with fatal collision investigations, but also tackling vehicle crime in the areas that I was working in, and left the police in 2016 to start a company concentrating on how we can develop vehicle related investigations. And the vehicle just doesn't fit into a serious collision, but it also fits into a serious crime investigation as well. And we have the knowledge and experience of dealing and managing those serious complex investigations to see how we can interface the use of vehicle data into those investigations. So I just want to start by talking a little bit about the automotive industry, because I think it's going through quite a significant change at the moment. I'm just going to highlight a few factors that reinforce this really. We've got a global population of 7.7 billion people. Don't quote me on these statistics particularly, but it is said that more people are living today than have previously died. The median age of that global population is 31. It took 200,000 years for the population to reach 1 billion, but it only took 200 years to reach 7 billion. So as the global population grows, and with the median age of that population at 31, then perhaps the automotive industry, as some of us know it, who were maybe born before a certain period, where we enjoy driving vehicles and repairing vehicles through, say, a mechanical process, that may be shifting significantly at the moment due to the population mainly being young, the population growing into a digital age, and not having those desires around the automotive industry as maybe my peers or my parents may have had, for example. So I think that's quite important, the way that that community and that generation will drive that change because of the demands on their life as they expect it. We just look at the UK vehicle population, just to give you an idea. At the moment, with 38.9 million vehicles licensed, that's as of September last year. I've not got any up-to-date figures for this year. But when we consider that the UK's population is around 66 million, then over half the population have access to a vehicle potentially. We had 740,000 registered vehicles July, August, September of 2019. And that equates to 342 vehicles per hour coming off production lines and being registered in the UK, which is quite a significant figure when you think about, at the end of this presentation, potentially another 342 new vehicles with new and modern technology are rolling out onto the UK's roads. And we need to be acutely aware of the fact that they are modern. They have got a lot of technologies on that we're going to speak about, and they are going to be used in various criminal offences. Would you believe the Ford Fiesta is the most popular registered vehicle last year, and the most popular licensed vehicle with 1.5 million out of those 38.9. That's sometimes useful for us to know. And then finally, we have a significant increase in battery electric vehicles, mainly due to the Tesla 3, and increased by 234% from the Q3 18 to the Q3 19. So that's a significant jump, and we can already see the electric vehicle taking hold and becoming more popular as battery lives increase. So if we look at that in a graphical form, just to give an idea of the last 20 years on the fuel type of cars first registered in the UK, and I know we're broadcasting to a global audience, but you'll probably be able to find these sorts of figures for your own areas and chapters. But we can see that rise on the bottom there of the alternative fuels coming up, the significant drop with the diesel, petrol sort of remaining the same. And that's why I think electric vehicles and autonomous vehicles are making it a really challenging and interesting time for the automotive industry. And we are seeing a massive shift and transformation in the automotive space, probably as big as we have done for some considerable time. It is going to be a disruptive technology. I'm not saying the internal combustion engine will disappear completely, but it will probably become less popular than it has been over the last 20 to 30 years. When we consider that 20% of an internal combustion engine turns into power versus 90-95% of electric into power, a lot less moving parts. We can get a lot more for our money before wear and tear occurs on components. As battery prices drop, as technology does, as it's introduced, then we will see it become more affordable. And then will we see more the car as a service? And are we already there in some regards that, as I say, the younger generation perhaps don't want to own a car, and will car ownership disappear? This has been broadcast on various channels as a projected change in how the automotive industry will operate. When we consider that I think Americans only use the vehicle 4% of the time, then is it cost effective to own a vehicle in the future, or would it be more convenient when we don't have that passion for driving vehicles just to have them as a service? And you tie that in with autonomous driving, and you can see that that would be of benefit to certain individuals, whereby they're just paying for the vehicle as a service. They can still do other work and be productive in whatever business they may be in, and we could see a significant shift in car ownership and seeing the car as a service. Those electric vehicle impacts have a significant effect on certainly us as vehicle examiners, because we have to be aware around safety and the examination of those vehicles and new technologies that are going into them. And then the autonomous vehicle impacts on us is generally the flood of data. So quite an old slide now, because last time I checked we are in 2020, albeit it does seem to have ground to a halt earlier on this year with COVID. But we can see from that chart the amount of data that's going to be produced potentially by an autonomous vehicle, and how do we handle that, and what are we going to do with that? And that's coming from the new technologies that we're seeing on modern vehicles these days that are really already there, with some sort of screenshots from vehicles that are already on the road. So I think the electric vehicle and the autonomous vehicle are going to be significant features in being a disruptive technology, but changing the way and the face of autonomy and vehicles through this next sort of 10, 15 years. Okay, so how do we as investigators maximise the evidential potential of vehicle data? We devise strategies for vehicles, and we try to triage what may be worthwhile doing as part of an investigation and what may not be. So it's okay saying, oh, we've got a vehicle involved in an investigation and we need to download it or get some data from it to assist the investigation. But we have to remember that the vehicle population is massive, and there are still vehicles on the road that, you know, are aging vehicles, 10, 15 years old. And we have to try and get that understanding to investigators that, you know, a lot of the older vehicles perhaps don't have so much data on there that will be of use to investigations. So we have to question ourselves as to what vehicle do I have? What systems does it contain? What data types am I after as part of the investigation? And what value could it add to other digital strategies? So when we look at a new and modern vehicle, and this is just taken from Jaguar Land Rover, the new Defender that was launched last year, I believe. I think it was 12 months ago now. But we just look at some of the features that are within their advertisement brochure for this particular vehicle. And already as an investigator, there are things leaping out at me as regards, it's got a standalone SIM card for over-the-air downloads, but that SIM card could be talking to telecommunication masts that could be detailing interactions with those masts in certain areas. We've got in the cloud car service platform, so the manufacturer may hold some data on their servers around the vehicle, and vehicle data could be being sent from the vehicle to the manufacturer. Always connected. Advanced infotainment systems with another SIM card potentially on the vehicle as well. So when we do have a modern vehicle, we have all these things to consider in formulating a strategy for them. This screenshot is just taken from a privacy website around what data your vehicle may be giving away. And this is quite old, to be fair, but it's still very relevant to assessing what might be on a vehicle that you could use for investigation purposes. So that highlights a number of different systems on a vehicle, from an event data recorder, crash data retrieval, third-party monitoring from an OBD2 device, tyre pressure sensors, short-range radio, maybe a telematics control unit that's been fitted by an insurance company, the CAN bus system itself, and what that may be communicating with. With the key for the vehicle, the key may hold some data of relevance depending on the type of the investigation. The infotainment system that we'll talk about in a little bit more detail. And there are a whole host of features on a modern vehicle that could hold data. On top of that, we have the introduction more latterly in recent years of the apps, and we'll be all familiar, and I think you've had a presentation a couple of weeks ago, on NFC relay attacks potentially, with the introduction of, the smartphone being used as a key for the vehicle. But potentially there may be information within a smartphone around vehicle data if an app is a facility on the vehicle whereby interactions with the vehicle could have been documented or stored within those type of devices as well. we've then got to consider coordinating other digital evidence. So could the car, if the car has a Wi-Fi hotspot, could it have interacted with other digital devices in the areas that it's been to? Phones that could have come into the vehicle and been attached to the vehicle. Home routers, could the vehicle, if it's pulled up outside a house, show a connection to a home router? And even though we may not have a car, but we may have a scene of a serious crime at an address, could the home router contain information about a vehicle? Car's Bluetooth MAC address, could that be grabbed by automatic number plate readers? So we're trying to be mindful of what systems are on the vehicle so that we can assist investigations in respect of other digital strategies that may be going on. Most people may or may not be familiar with wiggle.net, but as we can see from this screenshot, that's a zoomed in shot of the map, but we've got evidence of a vehicle being at a certain location with the friendly name of the vehicle along with a unique identifier of Wi-Fi MAC address. So the scenes of crime have to be considered around the vehicle for digital opportunities too. And I just give an example of a vulnerability on Blackview's dash cam, so third-party dash cam that's been on the market for some time, whereby we may be able to access data from their servers due to insecurities on there as regards vehicle data. If we know that the vehicle contains a certain type of dash cam, that's just one example of third-party devices that may be on there. And you've got to be mindful of those type of vulnerabilities on third-party equipment that's coming into vehicles and being used on them. And there's been plenty of presentations around those vulnerabilities by penetration testing organisations that will expose those vulnerabilities. And as investigators, then we need to be mindful of maybe those vulnerabilities, where they've existed, who they've existed with, and whether or not they are part and parcel of a vehicle that we may be looking at for a serious crime investigation. So the other remote opportunities, we may not have the vehicle, but data could be residing elsewhere. It could be with a manufacturer themselves. If vehicle data has gone back to the manufacturer, could be with a third party, an insurance company. We've got a couple of third party trackers exampled here, that one plugged into the OBD port and another one that's an embedded system. Sorry, it's a manufacturer's own that's hidden on the vehicle. But we need to be mindful of those items as well when we're considering those investigations. E-call is obviously something that's been introduced more latterly, but most modern vehicles now that have gone into production post 2018 will have the e-call facility on there. It's a useful tool for the emergency services to assist in saving lives ultimately. When we look at the death toll for road collisions, we've got some figures here: 25,000 deaths in the European Union in 2017. Road death accounting for 2.2% deaths globally. It's the 9th highest killer. And there are opportunities from that type of system. So the embedded SIM card that performs that functionality, again, could be talking to telecommunication systems, and we could consider making applications around there. If we have a crash, then e-call could be generated, and there could be a voice recording that's held on, a third party who's handling that call on behalf of the manufacturer and who is interfacing with the emergency services to get assistance to that particular location. So in a serious crash, there may be voice recordings of what's gone on immediately after the collision, which are of great use to serious collision investigations. So taking all those sort of features, and I've only touched and scratched the surface, really, and give you an overview of what's out there, and I'm sure people could certainly highlight many, many more. But we have to try and make sense of all those systems in order to devise a strategy to see whether or not it is worth pursuing it, whether it's realistic, whether it's proportionate to the type of investigation that we're carrying out, and whether it's achievable. How we would do that is through existing knowledge and knowledge that we're building up as we're going forward as to what vehicles got what system and what data comes off that. But remotely, we've developed a unique lookup system in partnership with some other data companies that will, as soon as we put a registration number in, it will bring back the vehicle systems that are on that particular vehicle at the point of manufacture. So I'm not going to run through this in any great detail. There is a video on this particular system on our YouTube channel. If people want to see how this particular system works in any detail, then they can go onto that, and I'll share the link accordingly for those people that may want to see how that lookup system works. Tell us what audio and communication systems are on a vehicle. Tell us what safety and security features are on that vehicle. And before we started an investigation, we've got that information to hand. You know, some vehicles don't come with sat nav, so it might not be that we can exploit any journey data because it's just not had a sat nav fitted to it, despite some misconceptions that every new vehicle will have one. Some of them don't. So it's a useful tool for that. So the infotainment system is one of the main areas that we go to in order to get some vehicle data of interest to investigations. I'm not going to insult people's intelligence in regards to what is infotainment, but you know, the car stereo is how I would describe it in court. It's become an inbuilt satellite navigation system. It's become an interface for your mobile phone, for your digital world to be brought into the vehicle. But it is quite an integral module on a vehicle, and gives the driver quite a lot of information surrounding what's going on inside the vehicle, and takes a lot of data, perhaps from a lot of different sensors on that vehicle. So we've just got some basic infotainment systems of recent years on these slides, the left being BMW, the right from Ford, and then looking at the individual modules themselves that drive those systems and where data may reside on them. You know, we've got one where a hard drive would store data on it, and with another one where a chip may store data on it. And then we would look to try and read that data if we can, and see what's on there for us to be able to assist in investigation. And there are all sorts of different data types we can get from these systems that can assist various different investigations. I'll just list these on the slide. Okay, go back one. So there's quite a lot of different data types that we could see on an infotainment module, but they would be dependent on the manufacturer of that particular infotainment system, and the manufacturer of the vehicle, as well as to you know, which trim level of vehicle has got which system in. And it can cause quite a headache for investigators trying to work out what system may be on a vehicle as regards a module when we get you know, deep down into the vehicle to find out where that particular module is. And the automotive industry, you know, as it is, will use multiple tier 1 suppliers, so they can be manufactured by different you know, automotive companies that work in as tier 1s. And that can present its own challenges, even though on the face of it, it will do the same functionality in the vehicle, it may have a different architecture inside the unit itself. And sometimes until we get to a vehicle and open it up, we never know for certain what we're going to find in there. So some of the tools that we would use in order to recover this data, and depending again what we're going for, we look at diagnostic tools that are out there, either third party or manufacturer's own. If we're looking at crash data, for those crash investigators that may be tuned in, the Bosch CDR is an ever-growing supported system whereby we can quite easily access the airbag control module and have the last 5 seconds of the vehicle's activity up to the point of a collision. And albeit there is no legislation in Europe for that to be given up, a lot of manufacturers are giving that data up in respect of being able to access it and assist in the investigation of a crash. And if we go back to those figures around road death, there is a common cause between the communities to drive those figures down. And if we can get a better understanding of how collisions occurred in the investigation side of things, then that can help drive where we focus our attentions going forward in order to try and reduce road death. So that data can be quite critical in an investigation to help support some of the more traditional techniques that us as crash investigation would have had to employ over the last 20, 30 years that it's been in existence and beyond to a degree. There needs to be a hybrid of both vehicle data and physical evidence at a crash scene. So it's not necessarily the case where vehicle data alone would be sufficient to resolve some investigations, but it can certainly be there to complement the physical evidence that may be at the scene and to support the hypotheses of an investigator as to how a crash has happened. So we would use crash data retrieval tools in order to read those where they are supported. And when they're not supported, it does cause us quite an issue or a frustration from an investigator's point of view, because we may have one vehicle that is supported and we get that rich picture versus an X-crash that doesn't, and we're left with a question of, well, does it record or doesn't it record? Is it proprietary information that the manufacturer doesn't want to release, or is there a way that we can approach the manufacturer in order to establish whether or not it has recorded anything and have some assistance in then recovering that data in a readable format so we can understand it. We can read those chips at that level, but it's difficult work to reverse engineer some of the data that we find on there. But it's not to say that we can't use it to show that data has been recorded on a particular module. When we're looking at infotainment systems, one of the tools that we use, and we've been using it for some time, is Burla. So that will be a non-destructive process whereby hardware and software is used to interact with the infotainment module and for data to be pulled out through their software. And that's a really useful tool for us in respect of if we are going after infotainment data, connected devices, or maybe journey history, because it enables us to know that we've got a solution for a particular unit without having to cause any damage to it, and we get the data fairly quickly, and that is critical in some live serious investigations. It can really help make a case if we get that information out quickly and in a format that we can understand, pass that to investigation teams to then secure other evidence in other areas. And really, Burla have done a fantastic job to support this community of vehicle system forensics in devising these solutions to these systems that are on the vehicles. The problem that some investigators find is it's, again, similar to the airbag control module. We may have a supported system that gives a lot of data up, and we have a solution to get that data off the system using Burla. And then we may have another investigation where it's an unsupported module, or it's a new module that we've not seen before that's come to market, and it's how do we get the data from there? So that can cause some frustrations. But, you know, this is the automotive industry, and people have got to recognise that, you know, the amount of vehicles that are getting produced and the different makes and manufacturers that are getting produced, it will be very, very difficult to have a solution for each one of those vehicles immediately. So it's a challenging area for those of us that are practicing in it, and the only way that we'll solve it is through, you know, a community-based approach and information sharing between those partners that can facilitate and come together to devise solutions for systems such as infotainment systems or crash data, if we're talking about crash data. So when we are left with a unit that maybe is new to market and we don't have a solution for them, we may be back to digital forensic techniques that have been more common practice on computers and mobile phones that we are now having to apply to the automotive industry, whereby in the past we've never had to do that. And that can involve doing direct chip reads, rebuilding file systems, doing hard drive imaging and rebuilding file systems. And it is a very challenging area when we are doing it that way. We have to sometimes be destructive in the sense that we'll be removing a chip from a module, which then essentially would render the module destroyed in our eyes, in the sense that we wouldn't really want to put the chip back on and put that back into a vehicle if it was an undamaged car going back on the road. It can be expensive, because if you're looking to replace those modules, then they aren't cheap. So it's a very challenging area. So just moving on slightly, and we'll just give you some examples of those hard drives and chips. It's not beyond the realms of possibility that people want to try and destroy evidence to cover their tracks. If we look at this vehicle that was used in a serious crime investigation, most of the insides have been burnt out. You can see on this slide that is the taken from the front passenger side of the vehicle, and it leads into the center stack area where the infotainment system would be. And all you can see is sort of a melted mound of dash, but the fire has sort of melted the dash around the infotainment module on this vehicle. So we can see that now the gear stick to the right and the housing to the left, and then in the center we've got this sort of black mass. And when we chip that mass away, then we find the infotainment module itself is still there. And then when we carefully take that apart, move down to an optical drive that's in the top part of the unit, and then underneath that we can see there is a hard drive in the system that has been quite well protected, in the sense that the label is still intact, and we can still recover data from that. Slightly different vehicle and a different system, but again, in the center of the picture with the rust is the infotainment module, and because we've stripped hundreds of these when they are looking good, we know where the chip is on them, so we can attack the unit in a safe manner to know that we're not going to damage anything. We can see there's still some survival of the unit despite the fire. And on the right hand side of the screen where it's black, that's the chip which would contain some user data on this system. And once we take that chip off the board and turn it over, we can see that we've still got pins that we're able to still get a read from. And that's where we have to use digital forensic techniques in order to, recover data. And then once we've got that data, it's trying to make sense of it and move that forward for the investigation teams. Okay, so I'm just going to move on into the case study around Frankie. So this was an investigation whereby a organised crime group was attacking ATM machines, cash machines, stealing the cash machines and taking the money out of those units. And they've been doing this for over 12 months here in the UK and raked in just over £1 million from those thefts, causing in excess of 200,000 worth of damage. So £1.1 million annual salary, not too bad for that type of work, whereby you may only be working 30 days a year and only for a few minutes when you're actually working, committing the offences. So you can see the sort of tasks that UK law enforcement have got on their hands to try and track down who these people are, how they're doing the crimes, and then trying to prevent that money from, being in the wrong hands, and try to confiscate that under what we call proceeds of crime if they can do. It warrants serious investigation. So one of the vehicles that was used for a period of time is an Audi S4 on a 2018. First registered on the 13th of June 2018. We've got just some of the basic specs there from the vehicle: 354 brake horse, £38,000 worth of vehicle, not 16.4.7 and a top speed of 155. So that vehicle was stolen on the 26th of July. So the owner had only had it about a month before it was stolen, and then it was in the hands of the criminals for just over 6 weeks, till September 2018. I'll go back to the strategy. So this is just an extract from the lookup system that we've used. So we can see already before we go to the vehicle, it has got satellite navigation. It's got the MMI Navigation Plus and MMI Touch. It's got Bluetooth interface for hands-free phone connectivity. It's got keyless go. It's got 2 USB charging ports and auxiliary in. So already I can start to devise a strategy for this vehicle without having gone to it. And I can consider other digital areas of the investigation I might want to consider around the USB charging ports and auxiliary in that might be in there for other digital devices. I'll just see if these videos play, just to give you an idea of the vehicle. Not sure if those videos have come through or not. Quite high resolution videos.
Yeah, they didn't come through great, but people could get an idea of how the vehicle looked.
Yeah, so quite extensive damage to the rear of the vehicle. There's rocks and bricks on the front passenger seat to be used as weapons. But all in all, the vehicle, despite the damage to the rear, wasn't in too bad a condition. It still worked, and that was, the main thing for the suspects in respect to this case, that it worked. It was a high-powered vehicle. It is sometimes a vehicle of choice here in the UK to be used in serious organised crime because of its performance capabilities. It can quickly accelerate and get away from crime scenes fairly quickly. And if it gets into some sort of pursuit type situation, then it's quite a robust vehicle to deal with that as well. So we do see quite a lot of those vehicles being used and stolen for that type of activity. Here in the UK, I don't know what people experience abroad, but we certainly see quite a few of those types of vehicles used for that type of crime here in the UK. So when we go to examine the vehicle, we look at infotainment as a potential, line of investigation on this vehicle. And when we power the vehicle up, we find ourselves crossing the North Sea from Hull to Zeebrugge. We weren't in the North Sea when we were carrying this examination out. Why might the vehicle be showing it's in the North Sea? Because we've had damage caused to the infotainment module on this vehicle. So, a crowbar driven in to that particular component. And that's, in order to stop any potential tracking of the vehicle, by the suspects. So with evidence of external sat-navs being used, they're not using ones that are embedded to the vehicle, and we've got some evidence of that with charging ports for cables for portable sat-navs that can be brought in and removed from the vehicle. But we need to look at a wider picture from a digital strategy and consider that there may be third-party GPS devices at some point in the investigation that need to be found. So interestingly, on this vehicle, when we've gone to look at the main gateway that's under the back seat of the vehicle on this particular model, the external GPS antenna is disconnected and backup battery disconnected, and one of the networks disconnected. So that goes to show that with some people who've got some knowledge around automotive, and they've tried to disable some of the facilities on that vehicle in order to avoid being tracked. Obviously, the main gateway is responsible for a lot of the communication that goes on in the vehicle, both internally and then externally, and facilitating communications internally and externally. And we can see just beyond the middle connection port that the main connection port is still in there for the vehicle to operate still. So we start to look at diagnostics read on the vehicle. We're now starting to support our hypotheses around these systems being manipulated by the suspects because we've got open circuits on the microphone, open circuit on the speaker for emergency calling. So those components as well have been tampered with, potentially because if the vehicle's involved in a crash, then those voice recordings may not go across properly if there's been damage caused to those particular systems. We get a date and time of those instances, which is on the day of the theft of the vehicle. with other fault codes around deactivation of passenger side airbags. That's not uncommon for those to be deactivated on a vehicle that's been used in crime, because we all know that when an airbag hits our face, we're probably going to leave a lot of DNA on there. And then this is what we do to sort of maximise data opportunities from vehicles, is we will read, even though the car wasn't necessarily involved in a crash, we will still read the airbag control module if we can, just to see what events may have been stored on there. So on this, it's an unsupported vehicle for crash data, to be fair. But we would still read it in any event, just to show that we've attempted to do it and whether or not we've got anything back. When we did try it on this vehicle, we did recover the data that you see on the screen. So we did recover the fact that the vehicle did have some sort of crash detection on the 10th of August, which is in the time period that it had been stolen, at 1:44 in the morning. And we get a mileage and operating time of the vehicle for that. We then get that confirmed with diagnostics read to say that pedestrian protection crash data has been stored at the same time. So we can then feed that into investigation timelines. So in this particular case, we may have had an offence in the early hours of August, whereby on the 10th of August, whereby one of the offences took place, and then with this vehicle, recording an instance of a crash detection not long after it. So the inference may be that it is the same vehicle, or it is the vehicle that's been used. It's not putting it on the street, because we've no GPS data for there, but it's a little piece of a big jigsaw that's needed in serious organised crime investigations. And then, due to the nature, I suppose, of a modern vehicle and what it will record, with instances of clutch temperature too high, I'll leave that to the audience to decide why the clutch temperature may have been too high on a stolen vehicle at 3:52 in the morning. But we get other associated data with that, and it can be of use to investigation teams. Again, when we start to layer this up, that on another day, just after the commission of an offence, we have other information that supports our contention that the vehicle we've recovered is the one that's being used in crime. Despite the infotainment system having the crowbar in it, and as we've seen in the previous slides around, burnt out vehicles, we would still recover that and see whether or not any chips have been damaged. In this case, we're still able to access a chip on this particular module. We're having to do a direct read on it, but we identify from the internal boards, despite the damage you've seen to the external and the sort of entry point of the unit, inside it's still quite intact, and we identify where the memory chip would be on there, and then remove that in order for it to be read. And that's what we call a chip off. And we do a direct read of that chip, and then start to work on data reconstruction to see what's on there. In this particular instance, yes, we did have some journey data, but it was prior to the vehicle being stolen and before all that interference had taken place in respect of the GPS antenna being disconnected from the main gateway, and we don't have any data of that type over the period of time of the offences. When we're having to use all these different tools and all these different methods to recover this data, it's important to stress that if we're going to introduce it into the criminal justice system, certainly here in the UK, then we have to check that it's right and that we can rely on it. And we have to understand it, and that can involve quite a lot of testing of tools that we would use, and to show that they are accurate, and that we can validate the process. So it's okay saying the car was in use at a certain date and time, but how do we know that that's accurate? So the tools that we may use are subject to some validation and scrutiny. That particular vehicle did have 2 embedded SIM cards on it, one in the gateway and one in the infotainment system. So there would have been opportunities for telecom applications going on there. And this is just a point for investigators, really. You know, when we end up at court for that particular instance, you know, the court are wanting to know the relevance of the embedded SIM. What does it do? What's its functionality? Where's the data going? Etc. etc. So it's important for investigators to know that which eSIM they're dealing with, because there could be more than one. And now do you know which reference you've got from there? And then when you are trying to interpret that data and there may be some data missing on certain days, then have you physically examined the module that contains the embedded SIM? And as we can see from this example, you know, you may have physical damage to components where it's maybe not working as it was intended to when it came off the factory, and it's doing its best to do so, but it may not be working as it was intended to do. And without that examination, you're left with unanswered questions where the court may not want to or wish to rely on that particular evidence because of its vulnerability, or you've not been able to validate it by any of the validation methods that you might use as investigation teams, or that the community have done from research papers such as SAE over in the States that we can reference when we are trying to use a particular piece of data in investigation. So it can be a good intelligence tool, but sometimes to use that data going forward in court, then careful consideration needs to be given around that as to the reliability of it going forward. So that particular case gave us an opportunity, and at the time of the opportunity, it wasn't really our intentions to end up with what we have. We were fortunate that the police force in question, once the case was concluded, allowed us access to that vehicle in order to strip the components from it, to then build a rig so that we could effectively have a vehicle outside of the vehicle and have infotainment system working outside of there. So I have to mention James Wales, who is an Audi Master Tech who does work with us, because he has facilitated the building of the rig, and because I've come on to this presentation live, I was hoping he might be here to answer any questions that people may have around it if he has joined. But I'll run through the sort of basics as to what we've built, and then if there are any questions for James and he's here, then he should be able to answer them for you. So that is obviously the insides of an S4, and then the next slide should be the component parts that we recovered. So we've quite a number of components out of the vehicle. Front ADAS camera, working from top down, roof module with the SOS button, virtual cockpit, the MMI screen, climate control unit, convenience buttons, steering column module, steering wheel and steering wheel buttons, the ignition start and stop button, the MMI controller, the volume knob, the infotainment module, which you'd seen, body control module 1. And what isn't mentioned there is the spare key for this vehicle, because in order to get the vehicle to start outside of the car, we still needed the key to see the ignition for the ignition lock to be released so that we could still access the vehicle systems. whilst we had the infotainment unit and it had been damaged, and we did have the chip off, albeit it had been damaged, we did put the chip back on the board, and we did use the infotainment system successfully for a short period of time. But it did, after a while of being on for quite some time, one day, did go faulty. So we did have to replace that with a brand new unit. So it's had a brand new unit put in it, and it's also got the existing old unit at the side of it with the lid off, so people can see the internal makeup of the unit that's there. So if we show you the A4 topology as regards the networks and ECUs that are on that particular vehicle, and then the next slide will highlight what components that we've got. So we may have a third, perhaps, of the vehicle with those components. And then we have a couple of slides just to highlight where some of the modules are that we've taken from the vehicle in order to facilitate the building of the rig. With the graphics in respect of the infotainment module itself, so what connection ports do what. And this is the rig has become a opportunity for the vehicle system forensics community to access for sort of training purposes, and just to give people an overview of a vehicle system without it being in a car nice and neat and tidy with trim panels to hide all the wires that connect the various components together. It's an opportunity for certainly law enforcement and those people with an interest in the vehicle systems community in order to have a hands-on and look at a system on what was last year, a modern vehicle, and still is to a degree, and to get hands-on with it rather than having to take a car to pieces to demonstrate this to people. That's how the vehicle was left when it was released back to the insurance company. Wasn't too much of an issue. We did have the permission to take the components parts from it. We have to say thank you to West Mercia Serious Organised Crime Unit for allowing us access to the vehicle to take those parts from it, and also to James Wales at Audi for putting the rig together. So that's how we left the vehicle, and then this is how it looks now. We've put it into a number of flight cases because it has been at various conferences and B-sides events here in the UK. And as much as its introduction was to maybe show the complexities of a modern vehicle and for some learning opportunities, I think, as I said at the outset of the presentation, really, we've one foot in the world that we're working in at the moment, but we're also very mindful of the automotive cybersecurity risk. And certainly when this rig's been at some of the B-sides events, then it has been an opportunity for penetration testing on various systems that are on there, and we've had some successful sort of input of injecting messages onto the system in order to make changes to it. So it is there for the community, and we will get it to as many venues that we can do for people to have an opportunity to to work with it and to see it if people choose to do so. Unfortunately, the restrictions of COVID this year have meant that we've been inhibited from sort of going places with the rig as we intended to do, but it's certainly there for the future when the community starts to get moving again, as we're starting to maybe see now. But certainly not until 2021 will we be able to get the rig to a venue for those people that may be interested in hosting it. And I think that probably wraps up my presentation. I don't know whether or not there's any questions from the audience that I can answer. Some questions I might not be able to answer just because of the type of work that we're doing. And whether there are any questions for people around the rig, then if James is here, then he will be able to answer those either verbally or maybe in the chat room. But I'll hand back to yourself, John. If people do want to see what we're doing on a more regular basis, then you can catch us on the social channels of Twitter. You can find myself, Noel Lowdon, on LinkedIn. That's a place that I'm quite active. Or you can contact us through our website, phone number or email address there. But I'll hand back to yourself, John, or Sven.
Yep. Okay. So at first, thanks for the presentation. It was very interesting to see also some insights from your work and the background of it. So there are some small questions, or not so much in the chat. Maybe I start with a question from myself. So what would be interesting for me is if you got such a car and you start an investigation to find out what kind of data is inside and how you can extract the data and so on. Is it like that the car manufacturer or the manufacturer of some components helps you and provides you some information? Or is it also in the direction that you make a kind of reverse engineering to find out some memory stuff or some debug interfaces to extract the data? Or is it more mix up? Can you say a little bit in that direction, how it works normally?
Yeah, I mean, it's more the latter point you make. We don't really approach the tier one or the automotive, industry as a whole to assist in the main. Depends on the type of investigation. Sometimes we have, but we kind of met with, a little bit of resistance from that side. It's difficult sometimes having to go through protocols to get in touch with those people when they are abroad. And that's where I see the ASRG group and a community, a global community being able to facilitate that, because it's, a global market that, vehicles made from parts that probably come from all over the world. And it's difficult when you're working within jurisdictions of people's local area to be able to have that direct line in, I suppose, to the manufacturer or to the, component maker to say, could you assist with this? So I would say 9 times out of 10, we're on to just doing it ourselves and trying to work it out for ourselves as to what may be stored there and whether or not we can interpret it. We may get so far and say, listen, we found some data on your module. Could you explain what it is to us? Or in some rare occasions, we have approached the tier ones and they've, assisted. So we can then sometimes use that in the knowledge that if we have the same component again in a vehicle going forward, then that would be a viable line of inquiry. But in the main event, it's doing it ourselves rather than assistance from there. But, I speak probably for the vehicle system forensics community to say that it would go a long way if we did have, some protocols and lines of communication in there to assist when they can hopefully see the difficulties that we have to go to in order to try and get something that may be relatively easy, notwithstanding the issues that you have over privacy and brand protection. We're completely well aware of that.
Okay, so that means in that case, you have also some tools in place, like, for example, in a penetration test lab is used. So, for example, to find out the JTAG interface of a board or something. Is this correct?
Yeah. So we would potentially work that out. It's not an area that we personally have concentrated too much on. We're having to, because of the difficulties of sometimes getting into these systems, but we're more the end user of trying to get that data or speaking with the community and feeding back in what we do see in systems to try and then overcome a system to be able to get, you know, data from a vehicle or from a component.
Mm-hmm. Okay, then if I think in the direction where we are also working on at the moment in the automotive industry, so for example, we try to place some security features in the embedded devices, for example, though that not everyone can read out the information. Before you can read out the information, you have to authenticate somehow, for example, with the car manufacturer, or some parts of the information are protected in a special memory where you can have only access if you are authenticated. Then this means in that direction, you have to register in a manufacturer and get this authentication, or it makes a little bit your work more difficult. Do you just think about that aspect, or is it not really relevant for you?
So if the manufacturer requires some authentication from either us or law enforcement.
Yeah, so we are working on in the area to bring security mechanisms or measures in place. So for example, the data is stored only encrypted, and you need to know the key to decrypt it, for example, or some accesses to the device, also for the diagnosis, for example, are protected by so-called challenge response, where you have a smart card and a PIN, for example, to get access to the data.
Yeah. Then that that presents us with a challenge, to get that, and we're either working on methods to overcome it without the assistance of the manufacturer, or we need to develop some line of communication between the law enforcement agencies that can facilitate the communication to make sure that the right people and the applications are proportionate to what they're set out to achieve. So it may be that you've got some data that requires that challenge response overcoming that's really critical to a serious crime investigation, whereby maybe the manufacturer will consider disclosing that, but it's then making sure that it's not disclosed on, say, a really minor offence or for other purposes other than law enforcement, maybe. You've the other industry that are sitting sort of maybe at the back of this, the insurance industry, that again, some of this data would potentially assist. So you may not have a criminal investigation, but you may have, say, a serious injury, road traffic collision with life-changing injuries to somebody, whereby they may need a legitimate line of communication with the manufacturer in order to be able to access that data. So it's trying to coordinate, those lines of communication in order that the material can be accessed in those type of instances where perhaps it does warrant accessing.
Yeah, I think that will be the right approach. So if it's really authorized, that the information you need helps to make clear what happened during a crime or something like that, I think this should be also be possible to get this protected data. If it helps for this purpose.
Yeah, and that's what I mean. There's got to be processes in place to make sure the data can be disclosed, and if it is, the data is protected, and any further disclosure of it is managed correctly, and it's only used for those cases that warrant it.
There comes now also an interesting question. What do you see as the most challenge if you look in the near future for your work at the moment?
Probably privacy and the challenges that we've just spoken about in respect of manufacturers recognizing the need, and the automotive industry it has a need to make sure that systems are secure and are safe, so that we're not in a position whereby vehicles are vulnerable to cyber attacks to be taken over. That work by the manufacturers and the automotive community who are developing those systems and products are doing so rightly. Our challenges will be then trying to overcome those systems for investigative data, and I suppose it backs on to what we've just spoken about whether or not that can be made available through the manufacturer themselves. Those are the big challenges that I see going forward, in respect of privacy, personal data and privacy, and protecting the consumer, versus then somebody who's legitimately trying to assist a serious investigation, knowing that data exists there, and having to overcome those technological challenges that we've seen previously in computer forensics and mobile phone forensics.
Mm-hmm. Okay. The next, and maybe also for today, then the last question, but it's also interesting. Do you just work on an investigation as well when the car is still in field? So if it's still using in the road and you try to find something out remotely, for example?
I wouldn't want to answer that question.
Okay. So we need to understand because to the audience, this shows us maybe a tactic or strategy from the police, and of course they want to open everything for everyone.
Yeah, that's right.
Okay, so then thank you again for the nice presentation and also answering the questions. Then I would give the virtual microphone back to John to find the final words for today.
Yeah, Noel, from my side, thank you very much. I'm sure everyone that was in attendance today or is watching this in the future also really enjoyed it. Do you have any closing remarks before we end for tonight?
Yeah, just to say thank you for allowing us to come on and speak about some of the work we do, and to give the community a sort of a snapshot of the challenges that we face in the field that we're in. It's great to be given the opportunity to do that, so thank you.
Well, thank you very much, Noel. And yeah, so great. That's it for tonight, everyone. Thank you for joining. Please come join us next week for, I think it's artificial intelligence in detection mechanisms. So please come join us next week for the next ASRG live webinar. All right. Thank you very much. Have a good night. All right.